Today we're going to introduce the universal wave equation. So we can combine physical characteristics that you've already learned about a wave to calculate other items. One of those items is the speed of the wave. Now we haven't done this yet. We've calculated speed, but in terms of distance traveled divided by time. So we're going to take that old equation and substitute in wave characteristics to get the same types of measurements. So our old speed equation is velocity equals distance over time. So distance divided by time. Now we want to find the same basic characteristic. Distance divided by time is how we calculate and how we describe speed and velocity. So we still want to use variables that are measuring distance or a form of time, but we want to use them in terms of what we see in waves. So v is still our velocity, but instead of distance traveled, we want to use a distance measurement for waves, and one of those measurements is wavelength. Wavelength is something that we measure in meters, which is also a distance measurement. And we want to divide by something that is measured in time. So another wave characteristic that we measure in time is period. Period is measured in seconds. So meters per second, wavelength over period, is the same as meters per second, distance over time. But personally, I don't really like using division if I don't have to, because I make a lot of silly mistakes. So instead of dividing wavelength by period, we can make another substitution. What is one of the variables that is really closely related to period? That's right, frequency. So frequency is the inverse of the period. Frequency equals 1 over capital T. So if we take out that 1 over capital T and replace it with an F or a frequency, we can do that same math with multiplication. So since frequency equals 1 over period, I'm going to take this equation and simplify it a little bit. I'm going to separate things out. So V equals lambda stays the same, but I'm going to take away that fraction bar and just multiply by 1 over period, because that's all that division does really. And I can now see that 1 over period is the same as over here, so I can substitute frequency in and get rid of the division completely. So I'm going to cross this out because that's not our final equation. But we have velocity equals wavelength times frequency. Wavelength is still the same measurement in meters, but now frequency is measured in hertz, which is 1 divided by seconds. So that still gives us meters divided by seconds when we multiply. So when we have these three equations, this first one can be used when we want to do calculations of a church bell rang and you heard the sound 50 meters away after 1.2 seconds. What was the speed of the wave? The second one can be used if we have the situation of a wave has a wavelength of 2 meters. If the period is 3 seconds, what is the speed of the wave? And the third one we can use if we have a speed has a wavelength of 450 meters, it has a frequency of 300 hertz, what is the speed of that wave? So all three of these equations are valid choices, it just depends upon what characteristics are given to us in the problem. So we're going to look at two examples just to make sure we can straighten these out. So the first example. The frequency of a tuning fork is 1,000 hertz. If the wavelength is 35 centimeters, find the speed of the wave in meters per second. So the first thing I'm going to do is list my knowns and unknowns. They're asking me to solve for the speed, so that's my question mark. They tell me the frequency, which is 1,000 hertz, and they tell me the wavelength, which is 35 centimeters. Now it asks me for the final answer in meters per second, and it gives me wavelength in centimeters. So I want to convert that, and I'm going to do that first. So I know that there's 100 centimeters in 1 meter. So to go from centimeters to meters, I need to divide by 100, which is 0.35 meters. I can also do this by bouncing on the stair step 2 steps to the left, just depends upon how you learned it in class. Now, based on these three variables, v, f, and lambda, I'm going to use that third equation. So v equals lambda times frequency. V is my unknown, so I'm going to leave that as a variable. Lambda is 0.35, and frequency is 1,000. So I'm going to multiply those together and find out that the speed of the wave is 350 meters per second. Okay, so we used one of our new equations, but did the same type of math that we're used to. Now the second example is slightly different. A wave in a rope travels a speed of 2.5 meters per second. If the wavelength is 1.3 meters, what is the period of the wave? So again, I'm going to list out my knowns and unknowns. V is 2.5 meters per second. Lambda, or wavelength, is 1.3 meters. And capital T, or the period, is my question mark. So based on these three variables, I'm going to use the second equation given. So V equals lambda over period. I know V, so I'm going to plug in 2.5. I know lambda, so I'm going to plug in 1.3, and I don't know period. Now looking at this problem, period is in the bottom of a fraction bar. It is in the denominator. Most people try to instantly multiply by 1.3 thinking that they're separating out that fraction bar. It doesn't really get rid of it. So instead of multiplying by the number on top, we're going to multiply both sides by t. We do this because now we can cancel out these two variables because one was on the top of the fraction and one was on the bottom. So now we have 2.5t equals 1.3. And we want to separate out that 2.5 and that t, so we're going to divide both sides by 2.5. And I'm left with period equals 1.3 over 2.5. And my period is 0.52 seconds. Okay? So I hope that the practice problems made sense. If you have any questions, make sure you ask your teacher. But now you're going to practice with universal wave equations and calculating unknown variables. Thanks, guys.